Hi everybody. In this video we're going to look at two things: session variables and encrypting passwords. Session variables allow us to keep track of who the user is, to keep track of the session. So it would allow us to do something like this. Let me just go to Amazon here. So Amazon knows who I am and knows how many items I have currently in my cart. If I click here and look at this nice Paperwhite, it still keeps track, so I can visit a bunch of pages here, different pages, and it keeps track of who I am, how many items are in my cart. I can add, well, I don't want to customize that, but I can add items to my cart. Let's get to another item here in the list. Let's say I'll shop at the plain old Kindle. Add that to the cart. No, I don't want any of that stuff. So, and it keeps track of these from page to page. It remembers who I am and how many items are in the cart. This is interesting because by itself, HTTP is a stateless protocol. So without us doing anything, HTTP has no way of knowing that when I click on one page and then click on another page, that it's me doing the two clicks, it's the same person, rather that it's me doing the click to one page and you doing a click to someone else. So there's no way of maintaining state between two transactions. So there's really no, in HTTP by default, there's no way of really doing what Amazon wants to do. We have to be doing something special. We have to code it ourselves. So let's see how to do that. So here back to the RC Club page. I've added a little login feature. I'm not doing passwords right now. We'll do that later. But I can put in a person's name and a plane. I want to hit a submit button. And then I want to be kind of friendly. I want to make people think that we care about them. So I'm going to put their name and plane up here in the menu bar, regardless of what tab I click on, what page we're visiting, just so they know, hey, we know you're Ann. We like you. So let's see how to go about and do that. So here's the index HTML page, the page that renders what I just showed, or the template that renders what I just showed you there. And here's the little form I made, right? So there's two text fields, one for user, one for plane. There's a submit button. When a person hits submit, this code gets sent to whatever's handling, or this form gets sent to whatever code is handling that slash. In server PY, I've declared two global variables, username and user plane. Right now they're the empty strings. Here's the code that handles that slash that the form gets sent to. I say up here that I'm using the global variables that I just talked about, username and plane. I check if the user pressed that submit button, did they get here by pressing submit? If so, set the username to whatever name they typed into the form, and set the user plane to whatever they typed in the form. A little later down here, I say user equals the list, username, user plane. So I just made it a little more convenient and made one thing. And then when I pass things to the template, I also pass that list. And I do the same here. So in the officers page, I say there's some global variables. I create this user with the username and user plane and then pass it to the template. Here's where it gets realized. Let me find that. It's right there. So user 0 is the username. So it's going to be username colon whatever plane they're at. So that's my attempt at doing what Amazon does, keep track of users. So let's see how all that works. So here I have Ann. And here my plane is the UMX Radian. I like that plane. I didn't get the Radian bit. And let me scroll down to hit the submit button. And now up here we see it says Ann UMX Radian. That's cool. Let's take a look at club officers. Same business. Hey, it looks like we're getting somewhere. FPV lab. So we're good here for Ann. Let's try it with another user. So I'm going to switch browsers here. So here's my Safari browser. Here's the RC Club page, the same place I've been going. So now I'm going to have someone else log in, Ben. And Ben really likes the Easy Star. I'm going to submit that. Great. So here we have Ben liking the Easy Star. Club officers, FPV lab, everything looks really nice. Here I'm back at Ann. Club officers. Oh, it switched to Ben Easy Star. So here I'm logged in, I thought as Ann, and all of a sudden now I'm Ben. The reason is this. We have one code that's executing, one executable, and lots of people are using this code. It could be thousands of people logged into our site. So using global variables here, the last person that logged in, the global variables were in server, the last person that logged in would be the person that everyone is. So obviously this is not the way to do it. It might be useful for some other tasks, but not for this task. Let's see how we can do that. How we do that is using session variables. Session variables are a way of keeping state, so doing what Amazon does, or doing what most modern websites do. They're stored on the server side, not in the browser. So if we know something about cookies, we can store information in cookies, but that's a browser side thing. Session variables are server side. They persist across multiple pages. That's exactly what we want. There'd be little use for them if they didn't. And unlike cookies, there's no expiration date. They die when the session ends. And the session can end if we close the browser. And cookies can persist if we close the browser. That's sort of the good and bad about cookies, right? So they create a security problem because of that, but they make life convenient. You know, you close your browser, you open it up the next day, and bam, you're in Gmail or you're somewhere else. I have my cookies expire always when I close my browser for safety, but it's not as convenient. So session variables are different. Using them is actually fairly straightforward. So we start a session this way, so only once in our code we put this in, so we're importing the session module, and then we add this line about the secret key. The secret key is how a cookie is signed. So to implement session variables behind the scene, we don't do this, but this is how it works. There is a special key, a cookie, that keeps track of who we are. So all the important information is stored server side, but this cookie is not. It's the thing that identifies this person is from this session. And this is just a big random number. So let's go ahead and put that in on the server side. So here from Flask, in addition to importing all this stuff, I'm going to import session. Here I've also imported OS, that was part of the deal. And here I'm created the app, the Flask, and now I'm going to say app secret key equal. So now I'm going to generate this secret key. And whoops, sorry, I didn't get the dot. Encoded as hex. And that looks great. And I didn't get any errors there. So I've done this step, and now using them is very easy. It's just like using a Python dictionary. The session variables are stored in a dictionary called session. So we can set them like this, and we can use them just by referencing them. So let's see how we can change the code I just had there by using these session variables. So that was here. They're not going to be global variables anymore. So instead of setting this global variable from this, I'm going to set a session variable. Session username equals request form user. So if they press the submit button, I'm setting some session variables. And now I need to change this bit here. So first I'm going to see if those session variables are set or if they exist. So I'll just say if username in session. So that means if it is, that means that those variables are set. So then I'll just type from scratch. User equals session username what did I do? I didn't want this. Sorry, I screwed up. Let me fix that. Typing without thinking. All right, that sure looks a lot better. So the user is going to equal session username, session user plane. That looks good. So if it isn't set, I'll just say user equals the empty strings. Right, so if those variables are set, use them, else they're not going to be there. Actually, I need that then for... Oop, no, that would have not been good. Let me get rid of this. And get rid of this now. So I'm doing this for all the pages. I'll just do a few pages here. Whoops. Trying to line those up a little. I think they look aligned. Same thing here. So I'll stop with these. All right, that worked. And I believe I did it correctly. Well, let's give it a shot. Let's go to home. Well, that's encouraging. Nothing bombed out yet. All right. And UMX Radian. So now I get and UMX Radian up here. That's good. Let's just check. It's on the pages. I think I did it on this page as well. Cool. All right, now let me get my... That's not it. Sorry. Let me hit the right thing here. There we go. And let me just refresh this page. And it's empty because we didn't log in with the new version. Now Ben. And I have Ben Easy Star up here, and club officers, FPV, back home, everything looks good. Now here's where we had the problem before, but let me go home, and I still have Ann here. So using session variables can keep track of things from page to page per user or per browser. So this is really important. We're going to want to do this if we're going to implement something like a shopping site, or people are logging in for doing something like a Twitter type thing. We would need to use something like this. So that was session variables. Okay, and now I'd like to talk a bit about passwords. And instead of doing them in Flask, I'll just be kind of more clear by just doing them in PSQL itself on the terminal. So let me log in PSQL. Let me change the database to music. Let me see what I have there. I have the albums thing. And let me create a table for my users. I'm going to have people log in here. I'll just call it users. And they're going to have names. I'll just call it username. Let's get fancy. Here, Postgres allows the data type text. It's like varchar with nearly unlimited length of strings. The difference between text, varchar or varying characters, and the characters or char that we see, if performance-wise, is pretty much non-existent. They're all very fast to use. So I'm going to just use text to vary it up and to make life easy for me. So it's not part of the SQL standard, but text is implemented in many database servers. So it's a fairly common thing. And I'll have password here be also text. All right, and now let me insert some users here. So Anne, my go-to person, her password is, let's say change me. And I have a user, Ben, and he has the password 12345. All right. Oh, that helps to get the syntax right. All right. Just make sure we have those. So we have Anne with a password change me and Ben 12345. This looks good, but here's the problem. We're storing the passwords in the clear, meaning we can, if we do this select statement, we can read those passwords. It's a very bad idea to do this. Every day we see announcements like passwords stolen, more than 2 million stolen passwords, popular passwords stolen from Adobe, 1, 2, 3, 4, 5, 6, and so on. Photoshop is a good password, apparently. And what we don't want is having our code contribute to having those passwords stolen. We'd feel really guilty, bad, stupid. You put in an adjective there, you'd feel if it was you that created the code that led to getting all these passwords stolen. So let's see what kind of smart practices we can do to get our passwords better protected. And what we'd like to do is we're going to encrypt the passwords before we store them. So maybe someone could break in, have some malicious attempt to break into our server and read these passwords. Or maybe some employee gets fired who had access to this password thing, grabs them just before he leaves because he's mad, and releases them onto the web. There could be lots of different scenarios we can develop that would lead to having all these passwords available. It'd be nice to have a system that no one at the company could read the passwords. You couldn't say, hey, what's my password? I lost it, because no one would have access to it. So that's the approach we're going to do. Let me get out of this. The first step we need to do is out of the database server, the PSQ, or the database client, PSQL. Also, let me give you a summary of what we're going to do before I do it. The first thing we're going to do is we need to install the little bit of code that's going to encrypt things for us. That's this code. And then for every database that we need this encryption, we need to create this extension for the database. And then there's this, I'm going to show you how to do it with Blowfish, the encryption algorithm. That's one of the better algorithms to use. I'll show you how to do it. It's very straightforward. And we'll go from there. So let's get started. We're going to do this sudo apt-get install. So that's what I'll do first. Sudo apt-get install PostgreSQL contrib. This relates, the 9.3 is what version of the database server we're running. And we see that when we start the database server. So when you start it, and you'll be starting it occasionally, you'll see that 9.3 occurring, or if you see 9.4, change it there instead of having the 9.3. Here's where it'll prompt us if we really want to do this. Yes. All right. And now let me make this big again, and let me go back into PSQL. And let me again switch to music. And now let me look at those. So I have users there, and when we selected them, we did this already, but I'll just do it again. We have Ann and Ben, and we can read those passwords. So the first thing I said we needed to do was, once we got into PSQL, was make sure we have that extension activated. And we do that by saying create extension PG for Postgres, I can't spell, PG crypto. That looks good to me. Let me see if it worked. Forgot the semicolon. So I created the extension. Now I can go ahead and use it. So now when I insert something into the database, again, if I want to do this in Flask, it's very similar. Don't forget the values this time. Okay, and so the user Clara, and now here's normally where I would have typed the password in the clear. I'm going to say encrypt this password. The password will be Clara's password, let's say is fancy. And then there's this Jen, we're going to salt, Blowfish. It's a very secure, and now let me get the right number of closing. I think that's the correct number of closing. And that worked. All right, and now let me do that select statement. So now you see fancy here, got encrypted is this. Let me change, let's say I'm going to insert Dora here. And Dora seems to have the same password. People love the password fancy, or 1, 2, 3, 4. Let's stick with fancy. And now let me show those. You see that they're different encryption values. So we can't look at a database of all these encrypted values and say, Dora and Clara have the same password, right? They look extremely different, or I guess there's some similarities, but they're different values. So what's nice about it is that even though people seem to have the same passwords, they're not. And to crack these, people say that for an 8-character password with just lowercase letters, it would take 246 years to crack on a standard PC. And for an 8-character password with upper and lowercase letters and numbers, it would take something like 251,000 years to crack. So this is a fairly secure password encryption technique. So to determine whether a person types in a password and it's the correct password, so a person's logging in and we want to check if that person's on our database, we do something like this. Select splat from users where name, it's username. Let's just go with the old approach first, and password. This is the before encryption technique. I think that was Anne's password. And we get the username and password. Let's see what we have to do here to do it if it's encrypted. Maybe I shouldn't have done that. We're going to alter that a bit, but first let me get to Clara, because that was the user that we have an encrypted password. So here, instead of typing whatever Clara typed in, let's say Clara typed in the word fancy. So that's what she types in. That's what she thinks her password is. And it does the crypt. It compares it with the password stored in the database there. And we get the result that yes, that is the correct password for Clara, because we got some result returned. Let's say Clara logs in and she thinks her password is 1, 2, 3, 4, 5, 6. It doesn't get a row done. So here's how we would use it to do the select statement. The insert again. Well, let's give me Enrique. And let's say he thinks his password is password. And we want to generate the salt using the blowfish algorithm here. And here's where I script that way. And so now I have Enrique. So I showed you both how to get stuff into the database and how to retrieve it or compare whether a person entered it incorrectly. Let me just make sure that works. Select splat from users. And I got them. So that's really the right way to do it. You need to do it this way. It's an embarrassment minimally an embarrassment to be storing passwords and that it looks like this. And it's fairly easy, as I showed you, to do. I hope that helps. Session's really important, and passwords are extremely important as well. Have fun coding.